Hello, everyone. My name is Zhuo Chen, and it's a great honor and pleasure for me to introduce our progress, work, and findings in past 6 weeks in JSALT 2020. Before my presentation, I would like to hope and wish everybody is having a good, safe, and enjoyable home working stage because it is a very special time. So now let's go back to our talk. So our topic is speech recognition and diarization for unsegmented multi-talker recordings with speaker overlaps. So it sounds very complex, but in short, it's very straightforward. So we are trying to handle the problem of who speak what at what time. On the unsegmented recordings, such as meeting, like we usually have like 1 hour meeting or even longer. That contains 2 to 8 speakers with around 15 to 25% of speech overlap. And this number is we get from statistics from the real meeting, from more than 100 real meetings, we get these ratios. And also the meeting could be recorded from different conditions and setups. So in the past decade, we observe a rapid growing research activities in all these relevant areas of meeting transcription, from the speech separation to speaker diarization with overlap handling, and to the multi-talker speech recognition, especially the multi-talker end-to-end speech recognition. But at the same time, we also observe that for most of those works, they suffer from 2 limitations. The first one is that most of those work focus on this specific part they are trying to handle. For example, speech separation people works usually focus exactly on the speech separation and ignore all its impact to the bigger picture. And meanwhile, a lot of unrealistic assumptions are made. For example, for the speech separation or the recognition, so people usually assume the accurate utterance boundary is provided for each mixture speech. But those information can be very hard to obtain in the real meeting scenarios. Or for example, some diarization algorithm assume that they know the number of speakers, or they don't even know the speaker ID, or they have a different speaker overlap ratios that is different with the real recordings. So therefore, that leads to our motivation of hosting this event. We propose that to try to bridge the research and this real-world problem on this unsegmented multi-talker recording on the realistic recording and overlap conditions. So we had our proposal. Our proposal was building and open sourcing the fully contained multi-talker audio transcription systems. And then on top of that, we plan to explore the novel modeling technologies for the processing. As we only have 6 weeks, so we have to concentrate ourselves to a more specific goal. So we concentrate ourselves in the data set called the LibreCSS. So this data set was released by Microsoft in April. And it is the real recording, 10 hours real recordings in a mid-sized meeting room. And the source data is the Libre speech, so that people replay the Libre speech in the meeting room and recorded by the multi-channel microphones. So it is good because the source is Libre speech, so that pretty perfectly match a lot of progress from the ASR community in recent years. And also they have a different overlap ratio from 10 to 40%. So that allows us to better understand and analyze the impact on the overlap ratio in different algorithms from the separation, diarization to the recognition. And meanwhile, we use additional 2-speaker and 5-speaker development set for better understanding the bigger picture. Then for the evaluation, we have 2 sets of measuring scheme. So the first one is the utterance-wise evaluation, where as many works, we assume that we have the ground truth boundary. So we segment each utterance out of the long recording and do the recognition or separation on individual utterances. And the other one is a continuous evaluation. So then this time they will take the whole long recording, which is 10 minutes per session, as the input and generate the long output and do the measure at once. So meanwhile we have also for those two conditions we have two metrics. The first one is that we call it the end-to-end evaluation. So we use the concatenated minimum permutation word error rate as the metric. And that is the same as used in the chime challenge. So it is a word error rate method that measures the particular speaker's activities and the speech recognition accuracies in one shot. So this measurement contains the impact on all three aspects, from separation, diarization to the recognition. Meanwhile, we also use the modularized evaluation, trying to have when we have a modularized update. For example, we use word error rate for speech recognition, diarization error rate for the diarization, and signal to distortion ratio for the speech separation work. So this year, because of the pandemic, everything is on the virtually is online. So we have a chance to have a larger number of people, and also because many people are interested in this, so we end up with a very big team. So we have 43 total numbers with 16 graduate students and 27 researchers. Among them, there are 14 full-time student members and 8 full-time senior members. And from all the members, 17 are from industry and 26 are from academic institutes. And then we have 12, overall we have 12 sites across 4 continents and 6 time zones. So it's very diverse. And meanwhile, it also creates a lot of challenge to us because, for example, when we have meetings, we will have it's hard to arrange. But luckily, I mean, eventually we seems to have a good outcome. We overcome those difficulties. So given that we have this large amount of members, we split into the 6 sub-teams, which focus on a different aspect of the bigger pictures, including the pipeline updating, long sequence modeling, E2 ESR for multi-talker, unsupervised learning, uncertainty modeling, and all neurals derivation and extraction. So after 6 weeks, so we achieved a bunch of deliverables. So I list some there, and most of them will be introduced in the later talks, more detailed talks, but I will just briefly mention those. So firstly, we have established the end-to-end evaluation pipeline. So we build a pipeline that can an evaluation framework on the LibreCSS. So from the input mixture wave, 1 channel or 7 channel, to the speaker attributed transcription. So we build a coding style that so people can just hit run.sh and getting everything done. That's including each parts. And then on top of that, we also have several exploration on the new algorithms and architectures from each aspect, as well as the joint modeling. So for the system, so we apply the continuous speech separation-based approach, so which is actually very straightforward. So given the input stream of speech in the long form, so we firstly process the input speech with a continuous speech separation module, and which route the input mixtures to the fixed number of output on mixed channel, such that in each of them it doesn't contain overlap. And then we call the diarization system on top of those, trying to find the speaker attribution and the clustering effect from each stream. And also we also explore some diarization directly applied on the mixture speech. And then finally, the recognition is called to get the final result, recognition result, to on each diarized segments. And then we can end up with something like this example, speaker 1, 2, 3, and say something like that. So this end-to-end pipeline, we actually shows that this is very effective because we started from the chime pipeline, chime-based pipeline, chime baseline pipeline, which is this spectral clustering-based hierarchical clustering-based derivation plus a single speaker-based recognition. So we start from that, and then we gradually add in different components, and we can see what error rate keep decreasing. And meanwhile, we can also see the derization error rate also decreased. So it seems that it's actually pretty helpful and working. Meanwhile, we also test different other separation algorithms, derization algorithm, and recognition algorithm. But some of them is under testing, and also because of the time, I didn't list all of them there. But we have a steady improvement on this pipeline. Then we move to the modularized exploration on different subjects. I will also briefly introduce those here. And again, the more detailed one will be presented by the members on each aspect. So from the speech separation, we overall have 6 projects focusing on the speaker inventory-based separation, long sequence modeling, convolutional beamformer, memory enhanced meeting separation, unsupervised speech separation, and speaker beam extraction. So from the result, we observed that each of the work actually reported positive results in either the SDR improvement or the word error rate reduction. I list some highlight here because it's very dense and too long, so I will not going to read it. But we can easily, with a glance, we can see they are quite effective. And then for the speaker derization, we explored 3 general aspects involving with 5 projects. The overlap-aware spectral clustering, data-driven end-to-end derization that includes and with their application on the LibreCSS dataset, and that includes the region proposal network and TS-VAD, target speaker VAD, and end-to-end derization with attractor network. And then we also explored the derization with uncertainty modeling. Again, from the highlight, we can see most of this algorithm actually lead to major reduction on top of the baseline. And note that this baseline is actually one of very strong baseline. Is the baseline we are using is the best system that in the die-hard challenge before. So it actually shows it's actually many of the algorithm is very powerful, at least for this LibreCSS data set. And finally, we have the speech recognition updates. So we explored the target speaker speech recognition on the hybrid model and the end-to-end model. Meanwhile, we do the architecture search by using this ResNet and TDN architecture, and as well as the MIMO speech multi-in, multi-out speech recognition on the LibreCSS dataset, and the end-to-end ASR with structural output. So the conclusion is also the same. So we observe major word error reduction on different setup. And also we are following the tradition from the JSALT workshop. We also advocate reproducible research in this one. So we plan to release all the code we are using, ranging from the data simulation to the end-to-end evaluation pipeline to the separation processing and the separation training and the derization training and then into ASR. So, but some of the code is still in the publishing stage, but we will make it open source in next couple of weeks. And there's some final wrap up is that I tried to save some time. So we built this end-to-end evaluation pipeline for this segment speech separation, derization, and recognition. We also explored the modularized updates. And during this period, we actually, one very important experiment we found is that when we are trying to port a lot of previous shown working system from a dataset such as WSG02 mix to this problem, we actually found a lot of conclusion is on the WSJ cannot be applied here. So which means that when we are working on more practical problem, we always have more findings. So we also encourage the researchers to evaluate their work on more practical problems with a realistic condition and a bigger view, so people on different subjects can see how their module can impact not only their task, but also the relevant task in the bigger picture. We hope that other researchers will also advocate this this practice. And at the end, so I would again to express my deep appreciation for the countless supports and efforts from everybody, from the JAG organizer, from Sanjeev, Yanda, Najim, and many other JSALT organizers, as well as our team member, full-time member, and part-time member, and everybody is very collaborative, so we can overcome the inefficient collaboration and the time difference, and end up with a good outcome. And finally, I would like to thank each organization, especially the industry organization, to allow their people to participate in this academic activities. And finally, we hope that the experience can also provide a good reference for future organization, especially this online type of collaboration. And that concludes my talk presentation. And then we will have a more detailed presentation one by one. And firstly, I think we will have the target speaker recognition. So target speech extraction. So from Dash, Katka, and Pavio.